We're going to graph exponential growth. Just the main thing I want you to be able to do by the end of this chapter is to be able to look at a graph and say, yes, this is exponential growth, or no, it's not, or this is one of the other types of graphs that we talked about this chapter. So we're not going to be too concerned about getting every little detail correct, or we're not going to look at this like we have in the past with shifting it left and right and up and down. We're just going to do these by plugging in a few values, getting a few points to plot, and then drawing the graph through those points. So let's look at y equals 2 to the x, very basic one, one of the simplest exponential growth equations that we could graph. We're just going to do this by making a table of values. And for our x's, let's choose a couple values on each side of 0. So -2, -1, 0, 1, and 2 will be good. Let's start with 0. If we plug in 0, 2 to the 0 is 1. Anything to the 0 power is 1. 2 to the first. So if we plug in 1, we would have 2 to the first. That's 2. Plug in 2. 2 to the second is 4. We can maybe add 3. 2 to the third would be 8. So now the negatives, think again about what it means when we plug in a negative. So when we plug in a -1 and we have 2 to the -1, that's the same as 1 over 2 to the first. So 2 to the negative first is just going to give us 1 over 2. 2 to the negative second is going to be 1 over 4. 2 to the negative third would be 1 over 8. Okay. So there's some points. We can plot those onto our graph. So 0, 1, 1, 2, 2, 4, and 3, 8 fits on there. With a lot of these graphs, it will not take long for your graph to go up and off your charts. Again, because they grow so fast. -1, a half, and -2, a fourth. We'll just do our best. Let's think about this real quick. What's going to happen as our graph goes far out to the left? We would keep plugging in larger and larger negative exponents, but those negative exponents are just going to give us smaller and smaller fractions. Right? Eventually we would have like 1 over 128. We'd have 1 over 512. We'd have 1 over 1024. Those are never going to get below 0. They're just going to get closer and closer to 0. So as we go out to the left, we never go below 0, but it basically looks like we're on the x-axis until we get to those points and we start increasing. Okay, so your graph should not go below the x-axis. It's going to stay right above it, but you're going to have very small positive values out that way. Let's complicate things for our next example a little bit more. We're just throwing in some extra terms, some extra steps to take as we calculate our outputs. So let's look at y equals 2 times 4 to the x plus 2 plus 1. Since we have this x plus 2 in our exponent, we maybe want to go a little bit further left, a little more negative on the x's that we plug in. Otherwise, we would start out pretty well above our smaller values to begin with. So let's look at -4, -3, -2, -1, 0, and maybe we'll get to 1. Let's start with -4. So I'm just going to talk through these. You might need to write them down on paper or plug them into a calculator to help you out. Hopefully we can get through these without making mistakes. But if we plug in -4, then in our exponent, -4 plus 2 is a -2. 4 to the -2 is going to be 1 over 16. Multiply that by 2, and that's 1/8. So plus 1 would be 1 and 1/8. Right, plugging in -3. -3 plus 2 is going to give us a -1. 4 to the negative first is going to be 1/4 times 2 is a half. Plus 1 is going to be 1 and 1/2. Plug in a -2. -2 plus 2, there's our 0. So 4 to the 0 is 1 times 2 is 2. Plus 1 gives us a 3. Plug in a -1. -1 plus 2 is 1, 4 to the first is 4, times 2 is 8, plus 1 gets us up to 9. So we are already getting close to the top of our graph. Maybe the last two might not fit on there. And plug in 0. 0 plus 2 is 2. 4 to the second is going to be 16. Times 2, 32, plus 1. That gets us up to 33. That's not going to fit. So let's not worry about plugging in 1 down there. So let's plot these. -1, 9, -2, 3, -3, 1.5, -4, 1 1/8. And let's think about this quick for a second. This is the term that as we plug in larger and larger negatives, it's going to get closer and closer to 0. But then we're always going to add 1. So for this one, that horizontal line that we'll be approaching is 1. Our graph is never going to go below y equals 1. So here we have our growth. And again, that's never going to get below y equals 1. It's pretty much horizontal there, but it is getting smaller and smaller as we go. Okay? So maybe if you noticed, the exponential growth really depends on the number that's the base of our exponent. The larger that number is, the faster things are going to be growing. Okay, so if you see that this is a 10, that's going to be growing real fast, and you're not going to have much room to graph something like that. Okay, but the larger this number is, the faster our exponential growth goes.